Characteristics of hearing. The story begins with a musical man, who plays guitar. Let's make him a heavy metal dude. And his name is Jason. Jason woke up one morning after a show the previous night, and he enjoyed the music so much that it got him thinking, how can he hear? How does the ear work? Jason thought back to the concert. Sound was coming out of the speakers, and these vibrations entered his ear. Let's look from the perspective of a musical note. For example, take the note G sharp. Here's a drawing of an ear. Sound is collected by the pinna and focused by the concha. This is known as the outer ear. Sound then travels down the external auditory canal and reaches the tympanic membrane, or the eardrum, causing it to vibrate. To G sharp, this journey would look like falling into a dark, scary pit. On the other side of the eardrum are the three smallest bones in your body: malleus, incus, and stapes. Vibrations hit the eardrum and are passed along the middle ear from bone to bone, much like a series of falling dominoes. The malleus is also known as the hammer, the incus is also known as the anvil, and the stapes is also known as the stirrup. Stapes is pressed against a snail-shaped structure called the cochlea, which is lined with tiny, fine hair receptors. These receptors move from sound waves, and their movement is much like Hawaiian girls doing the hula, and it depends on frequency and the amplitude of the sound waves. The movement of these hairs causes electrical impulses to occur, which travel up the auditory nerve to the brain and are registered as sound. On the cochlea are several tubes called the semicircular canals, and together they're called the labyrinth. These tubes are filled with fluid and are responsible for a sense of balance. Information about the motion of the fluid in these tubes is registered by the vestibular nerve and passed along to the brain. Remember the last time you spun around in a circle and felt dizzy after stopping. This is because of the fluids in the semicircular canals, which stop moving only after you're done spinning, so your brain still thinks you're in motion, and that's why you feel dizzy. Sound can be categorized by frequency. Really high frequency, past 20,000 Hz, is called ultrasound, and really low frequency below 20 Hz is called infrasound. Human hearing occurs between 20 and 20,000 Hz. You may be familiar with ultrasound images of a fetus. These images are created by placing an ultrasound probe on the mother, which transmits sound waves into the womb. The echoes of these waves, or the way they bounce back, can be translated into the shape of the fetus. Here's a video of an ultrasound of a heart. And this is my dad doing an ultrasound of my abdomen. The gel acts as a conductive medium for the ultrasound waves, which don't travel very well through the air. Some animals, like whales, elephants, and giraffes, can generate infrasound waves as a means of communication. Sound intensity is the rate at which power is transferred over a given area, in watts per meter squared. Threshold of hearing is the softest possible sound that we can hear, at 1 × 10⁻12 watts per meter squared, or 0 decibels. Threshold of pain is the level of sound intensity at which humans feel pain, at 130 decibels. For comparison, a rock concert is usually between 110 and 120 decibels, and a jet engine is 120 to 140 decibels. So, Jason, those are the basics of human hearing.